Well, now, we've seen forensic toxicology of alcohol. Now, let's deal with forensic toxicology of drugs and poisons. Now, if you don't remember, forensic toxicology is the forensic study of various compounds found in the body. Alcohol, drugs, poisons, maybe other things that you might need to know. But whatever it is, we have to study bodies live, samples from live bodies, or as part of the autopsy. We have to know about the chemicals inside the body. This will help us understand crimes that have gone on. Well, when a person takes alcohol, they usually drink a lot of it. And finding alcohol in the body is not that difficult because there's a lot of it in the body. When it comes to drugs, things are different. First of all, there's alcohol. That's just one thing. When it comes to drugs, there can be maybe even 1,000 of possible important drugs for a forensic analyst to find out how much there is. And the thing about alcohol, we know pretty well what happens. It slides right through the body. It doesn't get changed that much. Well, it does get changed by the liver, but then it's not alcohol anymore. It doesn't hurt anybody. Drugs, however, each one may have its own different metabolic pathway. Each drug can turn into something else as the body keeps on processing it. For example, you won't be able to find heroin in anyone's body. I mean, maybe you can, but generally speaking, the body immediately converts it to something like morphine. So it's not likely to find more heroin in a person who took drugs, even though they took a lot of heroin. So you have to know what things turn into, and for each drug, it may turn into something else. Or it might not change at all, but we have to understand every single drug. Well, maybe not us, but the forensic analyst who has to find the drug, the forensic toxicologist, has to know the metabolic pathways of all the drugs. Which one changes, which ones don't, what they change into, how to identify that the change was done. A lot of things to find out. Also, drugs are taken in smaller amounts. As mentioned before, you can drink, several cups of whiskey. Not advisable, but it's possible. And you can tell the alcohol from all that because there's a lot of it. But a person smokes marijuana, the smoke might get a little bit onto the drug. Whatever gets into the body, really only trace amounts. Not easy to find these. Even if you have a cadaver that you had a lot of sample from, it's not always easy to find trace amounts. And especially if you have a live person from whom you only have a blood sample, that might be even harder. Not only that, not only do you have to catch the drug, the trace amounts of drugs in the human body, you also have to find out how much of it. What's the toxicity threshold? Maybe such a minor amount was not even illegal or might not have impaired the person. So we have to know not only which drug was taken, but how much was taken, because that will affect the case against the person or maybe against somebody else who might have injected the drugs into them. If they injected a harmless amount, then we can't really put them on trial. But again, we have to know how much of the drug was there. And not only that, sometimes this toxicity threshold, the amount of drugs that will impair him, depends on the other drugs. If the person was drinking alcohol and someone injected him with heroin, that might make things, 3 times as bad. So even if he does a tiny amount of the heroin, the combination of alcohol and heroin might be really bad. I shouldn't have said heroin. I should say something like barbiturates, but it's the same idea. That drugs and alcohol or different kinds of drugs can multiply each other's effects. So you not only have to find the toxicity threshold of a single drug, you might have to find out what it is relative to the other toxins in the system. Furthermore, a drug analyst goes to the crime scene and tries to get an unknown powder. Yeah, they have to find out what it is, and it's not so easy. But they're dealing with milligrams of a substance. Okay, a thousandth of a gram. Roughly 2 or 3 crumbs. Again, that's an estimate of what it would be. So they have that amount. You can work with that. But the forensic toxicologist just either has a body or has a blood sample. The drugs in there they're in the microscale amounts. You'd be lucky if you could get 1/millionth of a gram or even nanograms. That's a billionth of a gram. We're talking about really, really tiny amounts that you have to be able to catch. So hopefully this illustrates the difficulty of the forensic toxicologist when they're dealing with drugs. And you should also have a lot of respect for the fact that they still get the results. They can still find these drugs. Methods are getting better and better, and they can nevertheless find these minuscule amounts of drugs in whatever samples they're taking and use it and have it hold up in a court of law. So they deserve a lot of respect for working with really, really tiny amounts. The fact is that a drug analyst, for example, and a forensic toxicologist, they both must work together, because a forensic toxicologist, they shouldn't have to waste time trying to eliminate possible drugs that really aren't there. It's better if the forensic toxicologist has a couple of hints about what drugs are or aren't there from the circumstances, and the drug analyst can sort of help them. The drug analyst, in this case, is somebody who takes the unknown powders at a crime scene and analyzes them for drugs. So if the forensic toxicologist has the information from the drug analyst who tells the forensic toxicologist, what we found at the crime scene was a white powder. And the forensic toxicologist will say, okay, well, I'm not going to be looking for Sinsamilla, or I don't know. There's some things that are just simply not white powders. So if it's a white powder, they might eliminate certain drugs and say, I'm not going to bother testing for marijuana. That's not a white powder. So I'll be testing for cocaine, maybe heroin, or something like that. They will know what to eliminate. So the work will be a lot easier and a lot better if the forensic toxicologist can have some kind of conversation with the drug analyst. But it's not just these two. The forensic toxicologist should work with everyone else at the crime scene. For example, they might have noticed in the crime lab there was a lot of glassware. Well, some types of drug laboratories don't require a lot of glassware. Or, again, many possibilities. When they say what was found at the crime scene, well, the forensic toxicologist can say, well, the person who was injected with the drugs probably has what they had at the crime scene. They're not going to bother testing for things that were obviously not at the crime scene. So working together, the forensic toxicologist working together with the drug analyst or the people at the crime scene, and also, let's say, the attending physician, the doctor that was working with, let's say, the victim of a poisoning. The forensic toxicologist should have some kind of conversation, should get information from the attending physician. When the attending physician will tell the symptoms, the forensic toxicologist will say, oh yeah, that is a sign of a hallucinogen. So I'll be testing for hallucinogens in their blood sample. Or they can say, no, it was a depressant. So again, this will enable the forensic toxicologist to focus and to get their job done better. Unfortunately, this cooperation between the forensic toxicologist and all the others involved in the crime is not as good as it should be. But it certainly would help the forensic toxicologist. So there's a lot of, again, the police investigator, all these people, they really should get together with the forensic toxicologist. That would help a lot with their job. Now, if the forensic toxicologist has a cadaver, they can pretty much get enough